welcome to my YouTube channel. It's your boy Noble Hero, and we have a question here. You can pause the video and try it. All right. So the question that we have here is x plus y plus z equal to 1. X squared plus y squared plus z squared equal to 69. And then we have that x cubed plus y cubed plus z cubed equals to 271. And we have to find the value of x, y, and z. All right, so now to approach this question, we'll start by expanding x plus y plus z to the power of 2. And an easy way to do this is to take x as one entity, and then we're going to group y and z as one entity. And then we are going to use Pascal triangle principle to expand that, where the coefficient is going to be 1, 2, 1. So, and then the power of x here is going to decrease from the highest power, which is 2, while the coefficient or the power of y plus z is going to decrease from 0 to 2. It's going to increase from 0 to 2, sorry. Alright, so let's do this. This is equation 1. X plus y plus z is equation 1 and it's equal to 1. So on one side of the equation, we can say that 1 square equal to, now we're going to expand this. Now expanding this, we're going to have x squared. Alright, so now x is with the highest power, with a coefficient of 1, while this is going to be with the lowest power, which is 0. And if it is with 0, the power is going to give us 1. 1 times this is still this. And then at the second point, the coefficient will be 2. And now x is going to decrease from the power of 2 to power of 1, while y plus z is going to increase from 0 it was at this point to 1. Okay, and then the last coefficient is going to be 1, so I'm not going to write that down. Now x is going to increase from 2 to 1 to 0, so we won't have x here. And then y plus z is going to increase from 0 to 1 and from 1 to power of 2. Alright, so let's expand this. So we further expand this to have this x squared. This is going to multiply to this, so we have 2xy. This is going to multiply to this. We have 2xz. And then for this one, we're going to expand it. And we're expanding it based on the same principle. So y is going to have the highest power, which is 2. And then 2y is going to have, the power is going to decrease from 2 to 1. Yz is going to increase from 0 to 1. And then z squared, where y has decreased to 0. And then z has increased to 2. Okay, now 1 squared is going to give us 1. Now we've found that we have x squared, we have y squared, and we have z squared, and that's our equation 2. And equation 2 says that that is equal to 69. So we can say that 1 here, and we have 69, which is as a result of this, this, and this. So we can write the remaining. So we are left with 2xy, and then 2xz, and then 2yz. All right, now we can move 69 to this side so that we have minus 69. 1 minus 69 will give us a minus 68. So minus 68 equals to 2xy plus 2xz plus 2yz. All right, so if you look at this now, everything is a product of 2, so we can divide everything by 2. So divide this by 2, this is going to give me minus 34, and this by 2 we have xy, this by 2 we have xz, this by 2 we have yz. All right, so we're going to take this as an equation 4. So we're going to take this as an equation 4. All right, so I'm going to clean this off. All right, so this xy plus xz plus yz goes to make it negative 34, that is minus 34, and that's our equation 4. Now we're going to expand again, x plus y plus z now to the power of 3. And just like we did before, we're going to take x as one entity and then y plus z. We're going to put it together. All right, to the power of 3. Remember this one. So I'm going to put that as 1 cube equals to, we're going to expand this. Now, since it's the power of 3, the coefficient that we're going to work with is going to be 1, 3, 3, 1. All right, so remember that 1, 3, 3, 1. Now, x is going to carry the highest power 3, and then the power will be decreasing from 3 to 0. That's 3 to 1, 0. While y plus z is going to increase from 0 to 1, 2, and then 3. All right. So, first coefficient is 1, so I'm not going to write any number there. And then we have x to the highest power 3. All right. Now, this is going to have the lowest power, which is 0. So, this with the power of 0 makes it 1. 1 times is still this. All right. Now, the next point, the coefficient is 3. First variable, which is x, the power is going to decrease from 3 to 2. While this y plus z, the power is going to increase from 0 at this point to 1. And then plus 3, coefficient is 3 again. Remember I said 1, 3, 3, 1. So this 1, 3, 3. Now x is going to decrease again from 2 to 1, while y plus z, the power is going to increase from 1 here to 2. And then the last coefficient is 1, so I'm not going to write any number there. And then x is going to decrease from 1 to 0. So we won't have x on that side. And then this is going to increase to 3. So we now have y plus z to the power of 3. All right, so we continue now by further expanding this. So now this is 1. This is x raised to the power of 3. And this to this we have 3 x squared y. This to this we have 3 x squared z. This to this we have 3 xy. Sorry. You have to expand this first. Sorry. You have to expand this. So we have 3x into the expansion of this will give you y squared, like we've done that before, plus 2yz plus z squared. All right. Then we are going to expand this. Now this is the power of 3, so we're still going to use the coefficient 1, 3, 3, 1. So this is going to be y raised to the power of 3 plus, write it here, 3 y squared z plus 3y z squared plus z to the power of 3. Now, at the end of the day, we have x cubed here, we have y cubed here, we have z cubed, and that's the same thing as equation 3. And x cubed plus y cubed plus z cubed is equal to 271. So this plus this will give us 271. So on this side we have 1 equals to 271. Then we're going to write the rest of the equation there, which involves 3x squared y and then 3x squared z and then 3xy squared. Then we have 6, this with this, x, y, z. This with this, we have 3x z squared. Okay? And then this which is 3y squared z plus 3y z squared. All right. Now we're going to move this to this other side. And that becomes 1 minus 271, and that should be negative 270. And then we have the rest of the equation, the rest of this equation, which is 3x x²y plus 3x²z plus 3x y² plus 6xyz plus 3xz² plus 3y²z, then the last, which is 3yz². Alright, so if you look at the equation here, everything is a product of 3. Everything is a product of 3, so we're going to divide 3 out. So if you divide 3 out of this equation, we're going to have a negative 90 on this side. And when you divide this by 3, you're going to have x²y. This is going to give us x²z. This is going to give xy². This is going to give 2xyz. This is going to give xz², then y²z, and then yc². Alright, so we're going to clean the rest of these so that we can continue. Okay, so now we have this minus 90 equal to x² y plus x²z plus xy² plus 2xyz plus xz² plus y²z plus yz². Alright, so now we're going to continue by, I'm going to write here minus 90, which is this, and then these we have x²y. Now we're going to write down every other element of x and y. We're going to write the ones that contains x and y. So this contains x and y, this contains x and y, so I'm going to write that down with it x y², and this contains x and y, so I'm going to pick one of it, x, y, and z, and then I'm going to group them together. Now the next one I'm going to take is the one that contains x and z. So the one that contains x and z, the first one that we have is this. So we have these as x and z. And then we have this that contains x and z. And so we'll write that as x, y, and z. And then the last one, which is this x z². Alright, so those are the one that contains x and z. Alright, so now the next one that contains x. Okay, now we're going to pick the one that contains y and z. Alright, so the one that contains y and z is these two. So I'm going to write that down. We have y²z plus yz². Now we need to also add xyz because we've added xyz to this one, xyz to this one. So we need to also add xyz to it. But if you add xyz to it, you've increased the number of xyz. Remember, we had 2 xyz here. This one. Now this is an extra one. So I need to subtract it out. Subtract that extra one out such that this equation is still the same as this. Okay, so now that we've gotten this, we can now factorize the common term here. So here we have minus 90 equal to the common term here is x and y. And if you pull it out of this equation, you're going to have x plus y plus z. That reminds us of equation 1. Alright, so plus, here we're going to factor out x and z out, and we're left with x plus y plus z. Alright, and then at the last point, at this point here, we're going to factor out y and z out, so that when we do that, we're left with y plus z plus x. Alright, then we'll put down the minus x, y, and z. Now we know that x plus y plus z, which is our equation 1, is equal to 1. So this is equal to 1. 1 times this is still going to be this. This is equal to 1. This times this is still going to be xz. This is still x, y, and z. So this is still 1. And 1 times this is still going to be yz. So at the end of the day, we have minus 90 equals to xy plus xz plus yz minus xyz. All right, but we know that this is equation 4, and that's equal to negative 34. So the equation now becomes, let me write it down here, now becomes negative 90 equals to negative 34 minus xy and z. All right, so here, if you move x, y, z to the left-hand side and negative 90 to the right-hand side, you now have that x, y, z equals to 90 minus 34. And 90 minus 34 is equal to 56. So x, y, z equals to 56. And this is our equation 5. So this is our equation 5. So I'm going to clean this off so that we can continue. All right, so now we have that x, y, z equal to 56 is our equation 5. So what we're going to do next now is to make x substitute the formula in equation 1 and substitute it into equation 4 and into equation 5. All right, so let's do that. So from equation 1, we have that x is equal to 1 minus y minus z. We're going to sub that into equation 4. So when we do that, we're going to have 1 minus y minus z multiplied to y plus 1 minus y minus z multiplied to z plus yz equals to negative 34. Okay? And here we're going to put this back. So we're going to have here 1 minus y squared minus yz plus z minus yz minus z squared plus yz equals to minus 34. Sorry, this with this is going to give it y. This with this is going to give it y. Sorry, not 1, y. All right, so now from this point here, we have negative yz, another negative yz, so we have two negative yz and then a positive yz. So that was going to return the negativity to 1. Alright, so we can then write this as y minus y squared minus yz, because that's what we now have, and then plus z minus z squared equals to minus 34. Alright, let me just put it this way. These cancel these out, so we now have the rest of the equation so that you will not be confused. Alright, so this is what we have, and then we go to substituting these into equation 5. So I'm going to do something like this. Then we say substitute x equal to 1 minus y minus z into equation 5. And equation 5 start with x, so I'm going to write 1 minus y minus z, which represents x. And then we have yz, and that's equal to 56. Okay. Alright, so here I'm just going to multiply y into this equation. I can also do multiply only x into the equation, but let's multiply y. If you multiply y into the equation, we're going to have y minus y squared minus yz, and then we have z outside equals to 56. Now this equation here is the same as this equation to this point. Let me bracket it. This equation is the same as this. So which means that this equation is the same thing as y minus y squared minus yz is the same thing as 56 divided by z. That means I've divided both sides by z. Okay. So since this is equal to this, I can come back here. At this point, I'll put 56 over z, which is this. Then we now have this plus z minus z square equals to negative 34. Okay? Now I can multiply z to everything. Multiply z through. And if I do that, I'm going to have this equation here, which is 56 plus z times this, it is z square, z times this is going to give you z cube, z times this is going to give you negative 34z. Now, making it a perfect cubic equation, I'm going to move everything here to the right hand side, such that we now have z cube minus z square minus, this already is on this side, minus 34z. Then we move 56 minus 56 is equal to 0. And that's the cubic equation we're going to work on. So let me clean this off so that we can continue. All right, so we arrive at this equation, which is that z square minus z square minus 34z minus 56 equals to 0. So we're going to break this down to find the value of z. So now, the value of z, to find the value of z, we're going to find the factors of 56. And the factors of 56 are, we'll have plus or minus 1, we'll have plus or minus 2, we'll test it with plus or minus 4, we're going to test it with plus or minus 7, plus or minus 8, plus or minus 14, plus or minus 28, and then plus or minus 56. All right, so this will not give you the answer there. It's not going to give you 0. Now, when z is equal to minus 2, find out that d is going to give us 0. Let's check it out. You substitute here, z as minus 2, we're going to have minus 2 square cube, minus 2 raised to the power of 2 minus 34 multiplied to minus 2 minus 56. And we're going to test if this is going to give us 0. Now this is going to give you negative 8. This is going to give you negative 4. This is going to give you positive 68. And then we have negative 56. All right, so let's calculate the negativity here. This and this is going to give you negative 12, and this is going to give you negative 68. So this is going to be the same thing as 68 minus 68, and that's 0. So with this, we confirm that x equal to minus 2 is the solution to this equation. Another solution would be when z is equal to minus 4, and also when z is equal to 7. So these are the three possible solutions to this equation. All right, so now when z equal to minus 2, what would be the value of x and y? So we test it now by substituting z as minus 2 into equation 1. And if you do that to equation 1, it's going to be x plus y plus minus 2. That's x plus 1 minus 2. So we move the minus 2 to this side, it becomes 1 plus 2, which is 3. So we'll now have that. We have equation x plus y equals to 3. So that will be, let's say, equation A. And then we also substitute this into the second equation. And if you do that, this is going to be x squared plus y squared plus minus 2 squared, which is 4. You move 4 to this side, becomes 69 minus 4, which is 65. So we're going to have the second equation as x squared plus y squared equal to 65. So that will be equation B. Now we're going to substitute x from this equation here we're going to have that x is equal to 3 minus y. We're going to substitute into this equation such that we now have x as 3 minus y square plus y square equal to 65. Alright, so we break this down, and that should give us 9. That should give us 9 minus 6y plus y square, then plus this y square equal to 65. Okay, now this is a quadratic equation, so this becomes 2y square minus 6y, and then 65 comes over, that will become 9 minus 65. 9 minus 65 would be 56. So we have negative 56 equals to 0. So everything is a product of 2, so we can divide through by 2. And if you divide through by 2, you're going to have y square minus 3y minus 28 equals to 0. Alright, so we factorize this. And then to factorize this, we're going to have y square minus 7y plus 4y plus minus 28 equal to 0. We're going to group these such that we have y into y minus 7 and 4 into y minus 7. So y minus 7 and y plus 4 is equal to 0. So from what we've done so far, found out that y will be equal to 7 or minus 4. Now, this corresponds with the values of x here, minus 4 and 7. And so that's pointing towards a particular statement there. Alright, so based on what we've done, x is negative 2, and then y have two values, which is negative 4 and 7. So let's say y is negative 4. Now, what's going to be the value of x? Alright, so now we're going to substitute these two into equation 1 such that we have x, and remember x again, x is equal to 1 minus y minus z. So we can just use that 1 minus 4 minus 2. So this becomes 1 plus 4 plus 2, and that's 7. So which means that if x is 7, y will be minus 4, and z will be minus 2. And these values can be interchanged. So that means x can be 7, can be minus 2, and can also be minus 4. Y can also be the same values. So the positive and possible answers here would be where we have x, y, z. The values can be minus 2, minus 4, 7. It could also be minus 2, 7, minus 4. It could also be minus 4, 7, minus 2. It could also be minus 4, 2, minus 4, minus 2, 7. Alright, so it can also be 7, minus 4, minus 2, or 7, minus 2, minus 4. So these are the possible answers there. But the answers falls between minus 2, minus 4, and 7. Alright, I hope the video was interesting and you learned something out of it. I hope you liked the video. Please subscribe and show me some love by subscribing, and like the video, share the video to those that you know would be interested in learning and watching. Alright, still remain your boy, Noble Hero, and thank you for watching.